In this capsule, we'll look at carbocation rearrangements, and they're often found in reactions. In our series of capsules, we have not introduced the reactions of alkenes. So here I'm introducing the reactions of alkenes, which leads us to carbocation rearrangement. So this is a typical reaction between an alkene and an acid, haloacid, like HCl, HBr, HI. So halogen acid, acids from halogen, so HBr, HCl, HI, so on. So this reaction, normally we expect this reaction to produce product 1, but it also produces product 2. We are here to explain how these products are formed and what is involved in that. So what happens when you mix two different compounds, any two compounds? So if a reaction is happening, there is an electron flow, electrons are being transferred, and we have already seen that electron flow is shown through curved arrows. So we have curved arrows here. So the process, the mechanistic process, that's a word for that, how electrons are being transferred from one compound to another compound, it leads to something. Sometimes you get the product directly, sometimes you get an in between. It's not the final product, you get what is called an intermediate. So this particular reaction, we are looking at how product 1 forms, and then we'll move on to see how product 2 forms. So in the mechanism of this reaction, how product 1 forms, there are a couple of steps. So in step 1, the alkene, the double bond, compound with double bond, the double bond can be donated. It has those electrons, double bond electrons can be donated, so it can act as a base. And the base, the alkene, the double bond compound is reacting with HBr. This has delta plus, delta minus, so the alkene double bond electrons flow and pick up the H plus, and the HBr bond breaks. So which results in what is called an intermediate. This is not the final product. So we have got this carbocation and bromide ion. So if you notice that carbocation, we can classify this carbocation as a secondary carbocation, because this carbon here is connected directly to one carbon and second carbon. So it's a secondary carbocation. Now in step 2, the intermediate, the secondary carbocation, traps the bromide. So there's a positive charge, there's a negative charge, so they come together from a bond, so we got this product. So this particular reaction has 2 mechanistic steps. In step 1, a carbocation formed, intermediate, and in step 2, the intermediate reacted with the other product of step 1, bromide, to form the desired product. Okay. So that's how the product 1 forms. But how does product 2 form? So just by looking at what we proposed in this mechanism, we proposed an intermediate, carbocation, and bromide reacted with the carbocation to form this product 1. So in order to form product 2, the carbocation that formed initially should somehow migrate to, if we're numbering them, carbon 1, carbon 2, carbon 3, carbon 4. So 1, 2, 3, 4. I'm just numbering the alkyl chain so we can talk about those carbons. So the intermediate here that formed is on carbon 2, and it is a secondary carbon, which trapped the bromide to form carbon 1. We already talked about that. But to form product 2, the carbocation must be on carbon 3. So somehow the intermediate carbocation, so if we have to write them here, the intermediate carbocation, which is this, let me write that in that. So the intermediate carbocation, this one, this is intermediate, somehow it must become this carbocation. Okay, so let's see how that happens. So there what you see, that's what we call carbocation rearrangement. The initially formed secondary carbocation rearranges to the secondary carbocation rearranges to tertiary carbocation. Why? Because tertiary carbocations are more stable than secondary carbocations. Okay. So how? We'll see that. How? Okay. So notice I have highlighted this hydrogen there. There's one hydrogen highlighted in green because I have a purpose for that hydrogen there. So this hydrogen, I mean, if we are going to just follow this along, just put the hydrogens there because we need to look at them. So there's one hydrogen on this carbon, there's one hydrogen on, now notice this one has two hydrogens. Okay, so how did that happen? This hydrogen on carbon 3, carbon 1, 2, 3, 4, the hydrogen on carbon 3, this bond, the carbon hydrogen bond shifted to carbon 2. We call it a 1,2 hydride shift. Okay? So the 1,2 just says that the two carbons that are involved are adjacent. The carbocation carbon is on, is on carbon 1, just that particular carbon, and the hydrogen is on carbon, the next carbon. So 2 and 3 are 1 and 2. So word used just to not say that the carbocation carbon and the hydrogen on the adjacent carbon are involved. So the hydrogen moves as hydride. Hydride is H minus. So this CH bond shifts to carbon 3. So you got that green one now here, as a result of which carbon 3 lost one of its electrons. So you got a tertiary carbocation there. Now the tertiary carbocation that formed by rearrangement, you got your initial carbocation, which is secondary, this is the initial carbocation that formed, which gave us product 1 here, but some of it rearranged to become the more stable tertiary carbocation, which then reacts with Br minus to form the other product 2. So this is one of the possible carbocation rearrangements. Then in the next capsule, we look at another short video involving a different carbocation rearrangement. Stop now.